Hi, welcome to my office. I'm Mishima, I'm a researcher in underwater acoustics. And today, I wanted to talk to you about a very interesting scientific article that I found. If you are not new on this channel, you know that I did an underwater acoustic recording of an underwater soundscape in a very particular location, Venezia in Italy. And I recorded the underwater soundscape of Calle della Donzella in the center of Venice. And I was very immersed by this experiment. It changed a lot of things in my view of underwater soundscape because of all this noise and how it was varied, this noise of boats, of ship traffic, and how few was acoustic life there. And then after, on Scopus, I searched articles, scientific articles. There are a few. I think from what I know, an underwater soundscape, there are 5. And today, I want to present you this paper. Is the Venice Lagoon noisy? First passive listening monitoring of the Venice Lagoon. Possible effects on the typical fish community. It is an article that was published in the journal Springer Nature in 2016 and was also presented in a conference, the 3rd International Conference on the Effect of Marine and Aquatic Life, Budapest, Hungary, July 2014. It was written by Marta Bolgan, Marta Picciolin, Antonio Codirin, Riccardo Fiorin, Matteo Zucchetta, and Stefano Malavisi. And let's dive together into this very beautiful and this pioneer article in underwater soundscape. Venice Lagoon is a complex ecosystem with a lot of diversity of marine environment. Since it's a lagoon, it's characterized by its inlets, the connection with the Adriatic Sea. From the north to the south, it's inlets Lido, Malamocco, and Chioggia. The 3 inlets, from what I understood, they have 3 different roles in this lagoon for men. The first, Lido, it's for the leisure traffic, the leisure boats, as well as the cruise boats. Then the second one, Malamocco, it's more for the commercial marine traffic because there is a city on the continent called Mestre, that has a big commercial port. And then Chioggia, that is more a fishing inlet. All those use of inlets will impact the underwater soundscape differently. I think I tell everything about the location. This article has 2 goals. The first one is to estimate what was called at that time the underwater ambient sound field of the Venice Lagoon. Now we name that the underwater soundscape of the Venice Lagoon. And the second goal of this article is to estimate the potential masking effect of the ship noise level on a fish species, the Brown Meagre. So scientific name of the Brown Meagre is Siaena umbra. In French we say le corbe. Why this is important? It's because high sound level can injure fish communities. And ship noise, it's a high sound level. So it's very interesting to understand how ship noise that is very predominant in the Venezia Lagoon can impact, with masking effect, can impact those communities. Why? To understand the evolution of a fish population like the Siaena umbra, and as well as to propose a measure, a regulation aiming at mitigating ship noise impact on those fish populations. So yes, the article was published in 2016. For me, I see it as a pioneer. Like you see, soundscape was even not mentioned. The soundscape concept didn't dive into the underwater acoustics yet. So let's have a look now at the methodology of this article. What is the methodology of those scientists? They recorded at 15 locations 11 of them was during the summer 2011, yes, is that. 10 was recorded in the two inlets Lido and Malamocco, and one, oh merde, hard to say this one, and one in Tenua d'Ancona. So this is for the summer 2011. They did also in September 2010, they recorded the ambient sound at 4 locations inside the Venice Island, so at the Arsenal Bacini and the Bacino San Marco. Je crois que j'ai bien dit. I think I said well. And with what they recorded? They recorded with a hydrophone that we call a pre-amplified hydrophone. This is my hydrophone. It's not a pre-amplified hydrophone because here there is only the hydrophone. A pre-amplified hydrophone has an amplificator just after the hydrophone to have directly amplified signal. Me, to amplify my signal, I need to do it with the zoom. So this hydrophone that they use has a frequency range from 5 Hz to 120 kHz. Mine, it's from 20 Hz to 20 kHz, then up to 120 kHz. A lot and a lot more. They recorded it with a Zoom H1 with a sample frequency of 44 kHz and 16 bits of resolution. So, like me, so this is the Zoom H5, then they have a Zoom H1. The Zoom H1 is much more compact. What can I say? Yes, 44. So, they have 120 kHz of frequency range on their hydrophone, but they recorded with a sample frequency of 44 kHz. If you know the theorem of Shannon-Nyquist, you know that when you record at a sample frequency, you can only record half the sample frequency. So they can record up to 22 kHz. So 100 kHz is lost. But is it really relevant to use this high frequency? I don't think so. Then, what did they do with this recording? How did they analyze it? They analyze by first calculating the sound pressure level. It's a logarithm matrix that tells us the intensity of the sound, the level of the acoustic pressure itself. So how much the sound is loud or not, you can say that. Sound pressure level, it's a decibel. I think it's what we have in mind. If you want to calculate sound pressure level, you have to do it in a frequency range. And then they use the 10 Hz, 20 kHz frequency range. So almost all the frequency range they can have with their recorder. So they calculate the sound pressure level for each second of each audio recordings, and then they average this sound pressure level to have an estimation of the average sound pressure level they have for each recordings. As well, they did another analysis for the recordings in the Venice Island. They calculate the sound pressure level of the third octave frequency. Third octave frequencies, it's a good way to separate the frequency band with a linear separation through the logarithm scale. It's hard vocabulary, but it's what we use. A logarithm scale, it's a scale that every decade has the same representation. In a graph, from 10 Hz to 100 Hz is the same as to 100 Hz to 1 kHz. Then they calculate this for the sound pressure level, but not for the whole frequency band, but for third octave frequencies. And this, you will see how they use it, it's very interesting. So, continue the video. And then, they identified call of the Brown Meagre. So the call of the Brown Meagre, from what I read, it's called a drumming call. They smash, they drum with muscles their string bladder. So it makes some. I have a djembe. It makes sounds like that. Voilà. This was the Brown Meagre sound made by Uxonio. Anyway, so they identified, they said orally, so by the ear, perhaps also by the using a spectrogram like Audacity, And they classified using the 3 categories from a work of Marta, another author of this article. Yes. So let's dive now into the results. So what is the result of those recordings? So first you are seeing it. This is the 3rd octave frequency sound pressure level at the Venice Island. And what do we see? Is that the sound pressure level of each frequencies are in between 108 dBs to 138 dBs. It's a lot. So, and you see that what I highlighted in red is what we call an audiogram. And this is an audiogram of the Brown Meagre. An audiogram tells us how much sound intensity a species needs to hear something. So what is below this curve, the Brown Meagre doesn't hear. What is above, it hears. And we can clearly see that the Brown Meagre is hearing most of the sound made in the bacino surmalco, in Venice Island, in Venezia Island. So it poses a recreation of masking effects. So when a Meagre is here, in this region, is continuously hearing noise of sheep. And what can happen is that this noise coming from sheep is mixed with sound coming from fish calls, so the drumming calls that I was talking you. And the sound, if the sound of the sheep is too loud, the Brown Meagre cannot hear properly the sound that it should hear. They use sound for signaling their presence, to say I'm here, to signal that they are eating, and also for breeding. And what happens if they don't hear breeding sounds? Male cannot hear that female can ovulate, or female doesn't hear that male are ready to, they have a, I'm not marine biologist, but perhaps it's the same thing, they have sperm and they can deliver their sperm on the eggs. I use ovulate, I think it's not good, it's just to spread eggs. I don't have the good vocabulary. Anyway, I was not supposed to talk about that. So if you know the good vocabulary for when a fish pour eggs for breeding, just put it in the comments, and the same for the male. I'm thrilled to know who is my marine biologist community. Anyway. So this is for the 3rd octave frequency, and the sound pressure levels, the mean sound pressure level calculated over all location. It's in between 108 dBs and 137.6 dBs. So it's very high level. Really, I can tell you, it's very high level. It's noisy there. Venice is noisy. It's a techno club for fish. And the mean level, so 108 dBs, is a mean level so of the source level of a Brown Meagre call. So what does it mean? Is that a Brown Meagre call emits sounds at the same level as the level that is in the Venice Lagoon. What is the problem? If you emit something with the level that the ambient sound is, it's not going to be heard very well. It's also a rising question on a potential masking effect made by sheep noise on the Brown Meagre calls. And as well, to finish, it's a good map that they show. They show the mean sound pressure level for each location, so Malamocco, Lido, and Venezia Island. The highest sound pressure level, mean sound pressure level, was in Malamocco inlets, then Lido inlets, and then Venezia. Why? Can be explained. Malamocco, it is merchant ship, so a commercial ship traffic, so big ship with big lengths, big motor, so it makes a lot of sound, a lot of noise. Then Lido, it's a passenger cruise, so as well a big ship that are making also noise, but less than merchant ship. And then after in Venezia Island, they go slower than at the beginning of the inlets. And you can see also cycles. It's a scale to represent how much calls of the Brown Meagre was heard in the 2 locations. And as well as the type, so R, C, I don't know. I do research and I tell you what is the meaning of those letters. So I dive for you in the articles of Marta, And yes, in the article she divided into 3 types of course, but I think that this division is also coming from another article made in 2001, the type I, that's I from irregular. That is when the pulse, I take my djembe, when the pulse are irregular. The type R, when the pulse are regular, so, but just one cold emission. The type C, it's chorus. A chorus, it's when it's continuous and is made by much more than one fish. So, you take 3 fingers and this is a chorus. And what do they find in this? That in Malamako and in Lido it was possible to hear cold sounds from Siaena umbra. Not I, most of them are, and as well so regular and chorus. So it's interesting. A lot of chorus at Malamoko, but not regular, and a lot not only chorus, just chorus and regular at Lido. Anyway, that is the results. Yeah. To discuss and conclude with this article, I think they responded to this question: is Venice a noisy place? Yes, it is. It is noisy because of the anthropogenic activity here, passenger cruise, leisure traffic, and merchant ship traffic. What they highlight also is that at Malmako you don't have a seasonal variability. The traffic from merchant ship is always the same. But in the Lido Inlet, because of the passenger cruise during the summer, there is variability in the soundscape. But the breeding season of the Brown Meagre is between spring and summer, and it is the moment where the sound is louder. So this sound can impact the life of this species, the Brown Meagre, as I said, with masking, and they highlight other type of impact. So horizontal vertical displacement, it can lead to a cortisol stress responses. So I think it's the Brown Meagre creates when he's under stress cortisol, and how it's going to impact cortisol in fish. I didn't dive into it. And increase of cardiac output. They put a good perspective that if the noise impact this Brown Meagre, it can impact other fish that are sensible to sound, that are present in this lagoon, and can impact fishery. You know, I told you about Chioggia, a lot of fishermen in Chioggia. Perhaps this sound impacts badly the fishing industry and the fishing industry in this region in lagoon. What did I say about this article? I have my little perspectives. Yeah. It's a good beginning to assess the Venice soundscape. A lot of location, I have to say, but only 20 minutes. It's not enough now when we do an underwater soundscape. It's better to have 1 year to put a remote, standalone hydrophone and record during 1 year the soundscape of Venice. Me, I'm very keen to know what is the variation within a year of this soundscape at those locations. Lido, Malmoko, I would like to have Chioggia also, and inside Venice. Why not close to Mestre, close to the big harbor? Would be nice. I find that the way the acoustic data is processed is a bit, it can go much more precisely. Like, for example, for the detection of the Brown Meagre, why not having a program, a code, that detects the number of calls and that detect the categories, the I, the R, and the C. I like these third octave views. Why not doing that for the Malmoko and the Lido inlets? Yes, to finish on this article, I would like to say that I really enjoy reading it because I see it as a pioneer in underwater soundscape science. And yeah, to have this idea in 2010, it's not so easy, I think. It was done for Siaena, from what I know. But it's good that to put the hydrophone, it's a good initiative. I like this. I really like the way it was written. like the way we have that. It really show us what it was. I really like it. Very easy to understand. If you want to read your first scientific article, it's a good one to start, I think. I hope you enjoyed also this article. I hope the way I presented with a bit of djembe. Perhaps I didn't go too much in detail. I was not too much pedagogic. Perhaps I didn't go too much at your level into underwater acoustic concepts like logarithm scale, sample level, etc., third octave frequencies. Tell me if you understand it well, because I really want to do other video like that on article that I enjoy a lot. And I want to know if I'm doing it well. So tell it to me in comments. Perhaps you notice it. I put in the background an Italian book. It's written by Moravia, Alberto Moravia. In French it's Nouvelle Romaine. I just did a search in Italian. It's Racconti Romani. So you are going to tell me why you put a book that talks about Rome, whereas you are talking about Venezia, and Venezia is on Roma, and Roma is not Venezia. First, I do whatever I want. Secondly, I will not tell it to you that it's because it's my only one Italian book that I have in my little biblioteca here. And secondly, what happened? Il Bambino, the first short story in this book, where the couple put the baby in Plaza de Venezia. So it's a bit linked with Venezia, this book. And as well, I'm sure that Moravia is very influenced by Venezia, and that Venezia is very influenced by Moravia and same. Anyway, so I can do it. And this is a book I'm reading right now. So it's Yukio Mishima, Le Pavillon d'Or, so the Golden Temple, let's say. It's a book that talks about the end of the war. I'm reading it, and I really enjoy it. And why do I show you? First, is because I'm reading it, and secondly, because underwater soundscape is very linked with the Japanese philosophy. If you know, if you have a little sensibility with Japan, I have some. If you see how they do for example, the haiku, a way of poetry there, simple, no so much word, and the writer, the poet, disappear in the poem, and he just tries to write a moment of life where he's not present. And underwater soundscape studies, it's a bit that. We put a hydrophone and then we disappear. We try to make the human, the scientific, disappear. We are spectator of the beautiful orchestra that is played underwater. I also have my two books offered by my grandfather, that is a bird lover. This one is a guide to understand the pelagic birds, the birds that only live out of the land, petrels, etc. And this is to identify birds in Europe that are on land. And yes, birds are very lovely animals. And yeah, I love birds. And to do this sound fishing, it's a bit like bird watching, sound fishing. And in somehow, I feel the same when I hear sounds, fish sounds, the same as when I'm looking birds, watching birds through my binoculars. Yes, so that's why they are here, because it's two words that communicate together, the underwater observation through underwater acoustics, and the birds observation through our vision, because the vision underwater is a sound, not the eyes. Yes. To finish, I wanted to dedicate this video to a very good friend, Riccardo Trentin. He's from the region of Venezia, more closer to Padova. He's my friend with who I had the talk that light in me this idea of sound fishing. It was in a surf session that we had here in Faro, and I had with him, by talking with him, this idea of buying a hydrophone. It's also him that invited me to Venezia, that permits me to do this beautiful video in Calle de la Donzella in the center of Venice Lagoon. He's much more scientific than me, He immersed me a bit in science, in how to think in science, and to spend time with him, I think made me a better scientist. He is a marine biologist specialized in algae, in microalgae in the Antarctica. So imagine, it's not a lot of people spend their mind to understand the microalgae in Antarctica. It's very beautiful to meet people like that. And he wrote articles, and while I'm talking, while I was preparing this video, I just realized that I didn't read one of his articles, perhaps because I was in my literature review. It's not a reason. Ricardo, I'm going to read one of your articles. It's him that helped me to pronounce those words, Malamoko, Kyoja, Tajuna, Dankona. Yes, it's finished this video of sound fishing, the first video that talk about an underwater acoustic article. And yeah, it's important. I think it's the most scientific. It's the beginning of going deeper into science here on this channel. Ciao.